Hello dear students, how are you all? Welcome to Tejuma YouTube channel. In this video, I am going to solve the 8th question paper of this series. I have been solving the mini question papers in which I have explained the solutions for multiple choice questions as well as the fill in the blanks. And in this video also I am going to do the same. I have already told you I am going to solve enough question papers so that you can score out of 4 in fill in the blanks and multiple choice question section in your upcoming board examination. Okay, so ee video saha nan same madake hogtidini. Let us move on to the question without any delay. So here the first question given: when a glass rod is rubbed with silk, it, option A, gains electron from silk, gives electron to silk, gains protons from silk, gives proton to silk. So one thing you should know, that is, gains proton from the silk and gives proton to the silk, it is impossible. These two are not at all possible because they will not move. Why? Because the protons and neutrons are present inside the ನ್ಯೂಕ್ಲಿಯಸ್. ಆಯಿತಾ, ನೀವು ಆಲ್ರೆಡಿ ಕಲ್ತಿರ್ತೀರಾ. ಇಲ್ಲಿ ನೋಡಿ, ನಾನು ನ್ಯೂಕ್ಲಿಯಸ್ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ ಅಂತಂದರೆ ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಪ್ರೋಟಾನ್ಸು ಮತ್ತು ನ್ಯೂಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ಪ್ರೋಟಾನ್ಸ್ ಆ್ಯಂಡ್ ನ್ಯೂಟ್ರಾನ್ಸ್. Okay, and they will not move, they will not come out of the nucleus at all. Only electrons which are present on the surface of the material will come out. Okay, illi so electrons aache barutte vinah protons neutrons aache barodilla. So option, what is that, C and D is not considerable, iverdu agode illa. And second case yavudide antandre, gains electron from silk, gives electron from silk. These two are possible. In this, which one is possible means, if you rub a silk cloth, if you rub a glass rod with a silk cloth, what happens is electrons move from glass rod to the silk cloth. Okay, do you remember that? So here it gives, what gives? Rod gives electrons to the silk. So option B is correct. Option B is correct. Now let us move on to the next question. Electric potential at the center of the charged hollow metallic sphere is 0, twice as that on the surface, half of that on the surface, same as that on the surface. Okay, ಈಗ ಇಲ್ಲೊಂದು ಮೆಟಾಲಿಕ್ ಹಾಲೋ ಸ್ಪಿಯರ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀವಿ ಅಂತಂದರೆ, ಮೆಟಾಲಿಕ್ ಹಾಲೋ ಸ್ಪಿಯರ್. Okay, so all the charges will be present on the surface, outer surface of the sphere. ಈ ಥರ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಔಟರ್ ಸರ್ಫೇಸ್ ಆಫ್ ಸ್ಪಿಯರ್ ಮೇಲೆ ಇದೆ ಅಂತಂದರೆ, ಸೊ ಇನ್ಸೈಡ್ ದಿ ಹ್ಯಾಲೋ ಸ್ಪಿಯರ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವಿಲ್ ಬಿ 0. ಸೊ ಇಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಈಸ್ 0, E is equal to minus dV by dx ಅಂತ ಒಂದು ಫಾರ್ಮುಲಾ ಇದೆ. ಇಫ್ ಇಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0, then what will be the value of V? It will be constant. So electric potential will be constant. Not only in this case, hollow sphere antalla, even if you consider the normal sphere, aita, so solid spherical shell consider ಮಾಡಿದ್ರು ಸಹ electric potential inside that will be constant. And we have already solved question like this. Now let us move to the next one. Which one is that? That is, which one of the following is the unit of capacitance? Farad, Coulomb, Volt, Tesla. It is the easiest question to answer. ಡೈರೆಕ್ಟ್ ಆನ್ಸರ್ ಮಾಡ್ಬೋದು ಫ್ಯಾರೆಡ್ ಅಂತ. ಬಟ್ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋಂಥ ಆಪ್ಷನ್ಸ್ ಯಾವುದೂ ಸಹ ಪ್ರಾಪರ್ ಆಗಿಲ್ಲ. ಯಾಕೆ ಅಂತಂದರೆ, ನಾವು ಯೂನಿಟ್ಸ್ ಬರೆಯುವಂಥ ಟೈಮಲ್ಲಿ, ಆಯಿತಾ, ಕ್ಯಾಪಿಟಲ್ ಎಫ್ ಇರಬಾರ್ದು ವರ್ಡ್ಸಲ್ಲಿ. ಸೊ ಇಟ್ ಶುಡ್ ಬಿ ಲೈಕ್ ದಿಸ್: ಸ್ಮಾಲ್ ಎಫ್, ARAD, ಫ್ಯಾರೆಡ್, ಆ್ಯಂಡ್ ಇಟ್ಸ್ ಸಿಂಬಲ್ ಈಸ್ capital F. Okay, so it should be small f, here it is small c, small v, small t. Okay, so the answer is this one, farad, capacitance ke. And coulomb is the SI unit of what? Charge, Q. And volt is the SI unit of potential difference. Nimge already gotthirutte. Tesla, magnetic field intensity, B. Next, we'll move on to the next question, that is the tolerance level of a resistor with the color code red, blue, orange and gold. ಇಲ್ಲಿ ಟಾಲರೆನ್ಸ್ ಅಂತ ಹೇಳಿರೋದ್ರಿಂದ ಸಿ ದಿ ಫೋರ್ತ್ ಕಲರ್ ರೆಪ್ರೆಸೆಂಟ್ ದಿ ಟಾಲರೆನ್ಸ್. ಓಕೆ, ಬಿ ಬಿ ರಾಯ್ ಗೋ ಟು ಬಾಂಬೆ ವಯಾ ಗೇಟ್ವೇ ವಿತ್ ಇಸ್ ವೈಫ್ ವಿಯರಿಂಗ್ ಗೋಲ್ಡ್ ಆ್ಯಂಡ್ ಸಿಲ್ವರ್ ಅಂತ ಓದಿದ್ದೀರಾ. ಓಕೆ, ಸೊ ಗೋಲ್ಡ್ ಆದರೆ ಟಾಲರೆನ್ಸ್ ಎಷ್ಟು ಬರುತ್ತೆ? ಟಾಲರೆನ್ಸ್ ಫಾರ್ ಗೋಲ್ಡ್ ಈಸ್ 5%, ಸಿಲ್ವರ್ ಈಸ್ 10%. ಡೂ ರಿಮೆಂಬರ್ ದಿಸ್, ಆಯಿತಾ? ಗೋಲ್ಡ್ 5%, ಸಿಲ್ವರ್ 10%. So here the answer is 5 gold 5%. That's why the option A is correct. Next, the magnetic field B, magnetic field near a current carrying conductor is given by, simple ಆಗಿ ಹೇಳ್ಬೋದು ಡೈರೆಕ್ಟ್ ಆಗಿ, Biot-Savart's law. Coulomb's law ಏನು ಕೊಡುತ್ತೆ? ಸೊ ಇಟ್ ಗಿವ್ಸ್ ದಿ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ಟೂ ಚಾರ್ಜಸ್, ದಟ್ ಈಸ್ 1 divided by 4 pi epsilon naught q1 q2 by r square. So Coulomb's law gives the force between two charged conductors or charged particles. They are separated by distance small r. Okay, so that is for force. Lenz's law, it gives the polarity of induced EMF. And here Kirchhoff's current law and Kirchhoff's voltage law is there, and that also you have already studied in Wheatstone bridge, right? Now the magnetic field is given by the Biot-Savart's law. Do remember that. So option C is correct. Next, Curie's temperature is the one above which the ferromagnetic material will become paramagnetic material. Aita? So this is very important concept. What is Curie's law and what is Curie's temperature? Okay, so ferromagnetic material like iron, which is so attractive, sensitive to magnetic field, it will get attracted by magnet suddenly. But when you heat it to particular extent, and if it crosses the Curie temperature ಗಿಂತಲೂ ಜಾಸ್ತಿ ಆಗೋದ್ರೆ ಹೀಟ್ ಏನಾಗುತ್ತೆ? ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಇಲ್ಲಿ 3 ಟೈಪ್ಸ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ಸ್ ಇದೆ. ಒಂದು ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್, ಇನ್ನೊಂದು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್, ಇನ್ನೊಂದು ಯಾವುದು? ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್. ಈ ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ಸ್ ತುಂಬ ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ, ದೇ ಅಟ್ರಾಕ್ಟ್ ಅ ಲಾಟ್. ಸೊ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ಸ್ ಸ್ವಲ್ಪ ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ, ಆ್ಯಂಡ್ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ಸು ಸ್ವಲ್ಪ ರಿಪೆಲ್ ಆಗುತ್ತೆ. Okay, so if the temperature is given to ferromagnetic material, and if it crosses the Curie's temperature, it will become paramagnetic material. Adu gottilla nimge. And then let us move on to the next question. The self inductance of a straight conductor is 0. ಯಾಕೆ? ಸ್ಟ್ರೈಟ್ ಕಂಡಕ್ಟರಲ್ಲಿ ಕಾಯಿಲೇ ಇರೋದಿಲ್ಲಲ್ಲ, ನಂಬರ್ ಆಫ್ ಕಾಯಿಲ್ಸ್. ಇಂಡಕ್ಟೆನ್ಸ್ ಅಂದರೆ ಇಂಡಕ್ಟರ್ ಇರಬೇಕು. ಓಕೆ, ಈ ಥರ ಇರಬೇಕು. ಸೊ ವಿ ಕನ್ಸಿಡರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಇಸ್ μ0 NIR, ಡಿಫ್ರೆಂಟ್ ಫಾರ್ಮುಲಾ ವಿ ರೈಟ್. ಓಕೆ, ಸೊ if you consider straight conductor, number of coils here is 0. ಆಯಿತಾ? ಸರ್ಕ್ಯುಲರ್ ಕಾಯಿಲೇ ಇಲ್ಲ, ಸೊ ಸೆಲ್ಫ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಈಸ್ ನಾಟ್ ದೇರ್. ಓಕೆ, ಸೊ ದಟ್ಸ್ ವೈ ದಿ ಸೆಲ್ಫ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಆಫ್ ಎ ಸ್ಟ್ರೈಟ್ ಕಂಡಕ್ಟರ್ ಈಸ್ 0. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲೇನಿದೆ? ಟು ಇಂಡ್ಯೂಸ್ ಆನ್ EMF in a coil, the linking magnetic field. So to induce EMF in a coil, let me consider a coil like this. Okay, so there is coil like this, and there is linking magnetic field. Okay, so option A, must decrease, can either increase or decrease, must remain constant, must increase. So you have been learning this particular concept from 8th standard itself. ಆಯಿತಾ? ಅವಾಗಲಿಂದ ಸಹ ಸ್ಟಡಿ ಮಾಡ್ಕೊಂಬಂದಿದ್ದೀವಿ. ಯಾವುದೋ ಒಂದು ಮ್ಯಾಗ್ನೆಟನ್ನು ಒಂದು ಕಾಯಿಲ್ ಹತ್ರ ನಿಯರ್ ತೊಗೊಂಡೋದ್ರು ಸಹ ಅಥವಾ ತುಂಬ ದೂರ ತೊಗೊಂಬಂದ್ರು ಸಹ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲಿಂಕ್ಡ್ ವಿತ್ ದಿ ಕಾಯಿಲ್ ವೇರೀಸ್. ದಟ್ಸ್ ವೈ ಇಟ್ ಇಂಡ್ಯೂಸಸ್ ದಿ EMF. ಆಯಿತಾ? ಸೊ EMF ಇಂಡ್ಯೂಸ್ಡ್ ಇಸ್ ಗಿವನ್ ಬೈ -d∅/dt ಅಂತ ಕಲ್ತಿರ್ತೀರ. ಓಕೆ, ಸೊ ದಟ್ಸ್ ವೈ ಸೊ ದಿಸ್ option B, can either increase or decrease, is the correct answer for this particular case. Next, the average power generated in an inductor, this comes in AC circuit, AC alternating current chapter. Okay, so average power generated in an inductor connected to AC source is 0. So in case of ಇಂಡಕ್ಟರ್ ಅಥವಾ what is that, capacitor. In both the cases, capacitor, in both the cases average power generated will be 0. Do remember that. It may be inductor or capacitor, but resistor bandaga bere formula baruthe, there is derivation for that. Okay, so next. Okay, next question here we have is, in an electromagnetic wave, direction of propagation of wave is in the direction of. See, if I consider, dear students, let me consider electromagnetic wave is moving in this direction. So this is the direction of propagation. Okay, and let me consider a electric field component of the wave is like this, and magnetic field component of wave is like this. Then this is the direction of vibration of electric field, and this is the direction of vibration of magnetic field. This is electric field and this is magnetic field. Then direction of propagation will be E cross B. Okay, E cross B. So now in the options, if you check, A is not correct answer, B is not correct answer, and B cross E is also not correct answer, and so it is none of this, because the answer is E cross B. Okay, now we'll move on to the next question. That is, the communication using optical fibers is based on the principle of. See, that is total internal reflection, because we have already discussed about this many times in the previous question papers. So total internal reflection is the correct answer. That is in case of optical fibers. See, optical fibers looks like this. Okay, so you might see these kind of pictures are the cases. What is that, in and around your home or workplace, somewhere else. Okay, so here you could see the propagation of light inside the optical fiber or a material, and which is getting internally reflected, and it travels longer distance in a short interval of time. That is, speed of light is given by 3 into 10 to the power 8 meter per second. ಓಕೆ, ಈ ಸ್ಪೀಡಲ್ಲಿ ಏನಾದರೂ ಟ್ರಾವೆಲ್ ಮಾಡಿದೆ ಅಂದರೆ ಲೈಟು ತುಂಬ ಕಮ್ಮಿ ಸಮಯದಲ್ಲಿ ಜಾಸ್ತಿ ಡಿಸ್ಟೆನ್ಸ್ ಟ್ರಾವೆಲ್ ಮಾಡುತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರ ಫಾರ್ ಇಂಟರ್ನೆಟ್ ಪರ್ಪಸ್ ಅಂಡ್ ಆಲ್ ವಿ ಯೂಸ್ ದಿಸ್ ಒನ್. Okay, now we'll move on to the next question, dear students. That is, colors in thin film are due to. thin film ಅಲ್ಲಿ ಈ ಥರ ಕಲರ್ಸ್ ಯಾಕೆ ಬರುತ್ತೆ? Why do we get? Think of it. How do we get colors like this? Okay, so it is mainly due to interference. See, light undergoes many different processes, phenomena. For example, if I say it undergoes reflection, bouncing back of light anta karitivi, refraction, bending of light when it moves from one medium to another medium, diffraction or diffraction. Okay, diffraction is also there, and it is total internal reflection or polarization. Like this, there are different phenomena, but in this case, what is the answer? It is called interference. Two or more waves superimpose each other and form different wave. So that is called light wave. That is called interference. So here the colors in thin film, ಅದಕ್ಕೆ ರೀಸನ್ ಏನು ಅಂತಂದರೆ ಇಂಟರ್ಫರೆನ್ಸ್ ಫೆನಾಮಿನನ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್, ಡೇವಿಡ್ಸನ್ ಜರ್ಮರ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ proved wave nature of electron, and we have discussed about this also in the previous question papers. Next, radius of nucleus is proportional to mass number, inversely proportional to its mass number, then proportional to cube root of its mass number, not related to mass number. See, we have the formula for radius of nucleus, r is equal to r naught a power 1 by 3. ಅಂದರೆ r is proportional to a power 1 by 3. ಇಲ್ಲಿ a ಅಂದರೆ ಏನು? ಮಾಸ್ ನಂಬರ್. ಸೊ a power 1 by 3 is nothing but cube root of a. So which option is correct here? Proportional to cube root of its mass number. ಇದು ಕರೆಕ್ಟ್ ಆದಂತಹ ಆನ್ಸರ್ ಆಗಿರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ we have for an NAND gate, which set of inputs A and B give a low output y is equal to 0. Y is equal to 0 NAND gate ಯಾವಾಗ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನು ಚೆಕ್ ಮಾಡಬೇಕು. Let me write here NAND gate. So if you write NAND gate here, so it looks like this, NAND gate. So this is AND gate. If you connect NOT gate in front of the output of the AND gate, you will get NAND gate. So let us consider here. This is A, this is B, this is Y. Okay, let me consider this is the output of AND gate, and here you will get A and B. Here you will get output A and B whole bar. Okay, so let me write the truth table. A, B, this is Y. A and B, we want the output of A and B whole bar. When do we get a 0 output? See 0, 0, 1, 1, 0, 0, 1, 0, 1. These are the combinations. You may give 0, 0, 2 inputs, 0, 1, 2 inputs, 1, 0, 2 inputs, and 1, 1, 2 inputs. And those are the inputs which are given here. Okay, 0, 0, 0, 1, 1, 0, 1, 1. For inputs. So for which one you will get output 0? Let me check. If it is 0, 0, the output will be 0. You can consider like this. This is into 0 into 0, 0, 0, 0, 1 into 1, 1. These are the outputs for AND gate. For NAND gate, it is the what is this opposite to this one? Means you have the complement here. Complement. So A and B whole bar is the complement of A and B. 1, 1, 1, 0. So you are getting 0 for this particular combination. So that is 1 and 1. Therefore here A and B should be on 1 and 1 ಇರಬೇಕು. I hope ಎಲ್ಲ ಕ್ವಶನ್ಸ್ ಅರ್ಥ ಆಗ್ತಾ ಇದೆ ಅನಿಸುತ್ತೆ dear students. Now we'll move on to the last concept of this particular question paper, that is fill in the blanks. So ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ? 0, diameter, gold leaf electroscope, photodiode, activity. Let me answer it from the last question. Dash is operated under reverse bias. ಇಲ್ಲಿ photodiode ಇದೆ ಅಲ್ವಾ, it works under reverse bias ಆಯ್ತಾ. So photodiode. One more diode is there. What is that? Zener diode. That also works in reverse bias. ನೆನ್ಪಿಟ್ಕೊಂಡಿರಿ. Next, the SI unit of dash is becquerel. It is the activity. Let me write here activity. Next, resolving power of microscope can be increased by increasing the, what is that? Diameter of objective. Diameter. Okay. Next, when a bar magnet of dipole moment M is placed in uniform magnetic field, the force acting on it, net force will be 0. The net force acting on a electric dipole placed in uniform magnetic field and magnetic dipole placed in uniform magnetic field, for both of them it is 0. So here if I consider the uniform magnetic field, okay, so here if I consider uniform magnetic field and put one bar magnet here, north pole, south pole, so it will what it will do? North pole this side, south pole this side. So here in this case, this may get repelled and this may get attracted, but the forces are equal and opposite. So net force will be F minus F, which is equal to 0. That's why the net force acting on the magnetic dipole or electric dipole placed in uniform magnetic field is 0. Next, last one. A simple apparatus to detect the the charge on a body is gold leaf electroscope. Gold leaf electroscope or just electroscope. Okay, so do remember this, dear students. Practice these kind of questions, more questions like this, so that you will able to answer, or you will able to attend many questions correctly. Okay, so try to solve many such questions, so that it will be helpful for your board examination, and share it to your friends also if it is useful. If you find this is very useful, please do share it to your friends. That's what that's what all I want. Okay, so we'll meet in the next video with a new question paper, and we'll be solving many more multiple choice questions. Okay, till then, take care. Bye bye.